So this is a quick overview of the project management topic of IPT. We've done all this in class before, but this is just for you to give you an overview for your exams. So the project management cycle we call UPDIT, which is understanding the problem, planning, designing, implementing, and testing and evaluating. So we follow that cycle no matter what type of system development cycle we use. Basically, all system development cycles follow that cycle, but some have longer, for example, in the designing phase, some have longer in the implementing phase. With understanding the problem, we find out problems with the existing systems. We do this by asking the people that use the system and participate in the system, and also possibly even people in the environment. We generally ask them in a structured way, either through interviews, surveys, or observations. How you observe the person using the system is often the most effective way to do it. You need to analyse the existing system. You would use different tools to do this. So for example, you might use context and data flow diagrams, or data dictionaries, or schemas, entity relational diagrams, or you might even use the information processes diagram to do this. But you need to figure out the way in which the system works so that you can figure out what any potential problems are with the system. You need to determine how it works, what it does, and who uses it. After that, you need to write the requirements report. The requirements report considers the constraints, outcomes, existing items used by the new system, things the system must do and use, and also it must be understandable to the client and developer. So the idea is that the client should be able to understand it, because if the client doesn't understand it and thinks that it promises more than it does, then you will have problems when you deliver the system and the client doesn't accept it. If the developer doesn't understand what the system is supposed to do, then you have bigger problems because the developer won't actually solve the problem. So if your requirements report isn't correct, then you will find that your solution in the end is not correct, because all of the system's cycle is based around the requirements report. A requirements prototype might be created at this stage, and what it is a working model of the information system. The idea is that you build a prototype of the system, so it may or may not be the actual system, and you would ask the users and participants to refine their ideas about what's wrong with the system by looking at progressive prototypes. Sometimes it's easier for users to explain what's wrong with the system when they're looking at an actual system. So they might go, well, I want that to be a drop-down menu, rather than explaining that without having the system in front of them. Sometimes you would start with a low-fidelity prototype, which means that it doesn't look anything like the system. So you might have a paper prototype of the system and work your way up to a high-fidelity prototype, which looks very much like the system and may actually have some working components. We use prototypes when the problem is not easily understood. So if the developer finds it difficult to understand what the problem is with the system, or if the users and participants find it difficult to communicate what the problem is, then we would use a prototype. The idea is that the repetitive process of building the prototype, having the participant feedback, modifying it, and then building any changes will eventually make a good system. We then would use that for the system that we would then use that for developing the system later. So we can use it as almost a design drawing for the new system. In the planning stage, we look at a feasibility study. So we need to look at a number of different feasibilities. So after you have figured out what the problem is, you might design 3 different alternative solutions to the problem. And you need to look at the feasibility of those solutions. So the feasibility has to do with the practicalness of actually creating the solution. So a solution might be possible without being practical. Feasibility study should include whether you can afford it, because sometimes it is better to stay with an old system rather than spend the cost of the new one, particularly if it's going to cost you a whole heap of money and the changes that are being made aren't worthwhile for that money. So maybe it might take somebody longer to do it, but it might be worthwhile spending longer on that process if it saves you a lot of money in the long term. The technical feasibility is whether you have the information technology available to do the job that you want. The operational feasibility has to do with the people in the system. So whether the people have the skills would be one thing, but also whether management supports the system and whether your management structures also support the possibility of creating that system. And scheduling is obviously time feasibility. So do you have the time to do it? Sometimes one of these feasibilities might be much more important than another. So, for example, if you're trying to create a reporting program and your reports are due next week, then obviously the time feasibility would be much more important than cost. So this is how I would do it in terms of a report. I would look at each solution and look at the technical time, operational, and that should read cost, feasibilities. So if you have a look in solution 1, you would have the technical area, and you would have a look at the technical requirements of solution 1, technical requirements of solution 2, and then balance them off against each other. If you have a look in your textbook, there's actually an example of this. This is Sam Davis's textbook. And if you have a look, they've actually given the technical feasibility there for option A. A negative is that PDAs must be purchased for each expert. A negative is that experts have various models of mobile phones, hence different interface cables. So they would be technical things because you need cables in order to transfer the information to your computer. And if most people have different phones, then most phones need different cables. A positive is, though, that most mobile phones contain inbuilt modem functionality, so you wouldn't have to purchase modems outside of the technology that you already have. So the good thing about this one is that they've actually put down a negative and a positive point for each one. So then in the end, you could weigh up all the positives and negatives and find out what your best solution is. Now again, obviously some things might have more weight, so you might decide that time is the most important, and even though you have a number of negatives in every other place, then your positives might outweigh, positives in time might outweigh your negatives in other sections. After you've decided what system you're going to do, then you need to choose an appropriate development approach. So there's traditional outsourcing, prototyping, customization, participant development, and agile methods. All of the processes follow the same basic system. And if you have a look in the center of the system, there are users. You need to consult with your users at all phases for a number of reasons. First of all, because the more you consult with users throughout the process, the more likely you are to get a solution that actually solves your problem. The other reason is that the more that you consult with users and the more that they feel that they have their say in how the system is developed, the more likely they are to actually accept the system when it comes into use. If your users don't accept the system and start to use it, your system may not work. So you either have to have a lot of user buy-in, we call it, because users are actually interested in the system and want to see it work, either because they see the advantage of it to their daily life, or because they feel that they've had a say in it, or because they're forced to do it. Often the least useful method of involving users is forcing them to do it. So if you can actually consult with them as the system goes along, then you're increasing the acceptance of users to the system. The traditional structure is what you would have done in a lot of your assignments, so you would have done a full portfolio. The traditional structure follows a formal structure. So each process follows one after the other sequentially, and each process is followed carefully. So you need to complete the understanding the problem stage before you move on to planning, and planning before you move on to designing. This is really well suited to large-scale problems because if you have a developer leave halfway through the system, then you won't have any problem with somebody picking it up and moving on with it. You probably wouldn't use it for a small system because there's a lot of documentation that's required in terms of how the solution is run, and sometimes the documentation can take longer than actually developing the system. So that would not be a good thing. There's also problems that if you have a problem in the understanding the problem stage and you don't pick that up, then that can be followed through to later stages. And as you go through to later stages, if a problem is not picked up, it becomes more and more expensive to fix it. Outsourcing. Sometimes you don't know how to solve a problem yourself, and it can be cheaper sometimes to go and find somebody and pay them to fix the problem rather than you learning the tools and equipment or the skills required to actually fix it yourself. With prototyping, it's similar to, there is a prototyping process in understanding the problem sometimes, but this prototyping cycle actually follows the structure much more weekly, but the main emphasis on it is the designing, testing, and evaluating the prototype. So you would give a user a prototype and the user would tell you what's wrong with it, you would go away and fix it, and then this cycle of progressively fixing, testing, fixing, testing, fixing, testing would eventually get you the system that you wanted. This is really good for difficult to define problems, so problems where the user can't tell you exactly what the problem is, and there's lots of user interaction, which basically means that the user feels like they've had a go at designing the system, which increases their acceptance of the system again. However, often this can blow out the size of the project, so a small project can get very big very quickly. Sometimes too, it's difficult to explain to users why things can't happen. So with their involvement in the system, because they are suddenly experts in the system, they can expect things to happen that aren't actually possible. Customization happens a lot. So for example, PM Online, we use an existing system called Moodle and we customize it to meet our needs. Rather than creating a whole new system where there's one already available, we can actually either buy, or if we use open source products, so Moodle is an open source product, and we can modify that in order to make it suitable for our needs. And often this is much cheaper and much more feasible than designing a whole new system. In participant development, there are more people that are participants in the system designing the system. So you would actually, if you needed a solution for yourself, then if you had some knowledge of, say, Excel, for example, you might just use Excel and push your knowledge just that little bit further to create a system that's suitable for us. So for example, we use the system that we use for the swimming carnival, we developed using participant development. So there's only 2 people that actually run the data on the swimming carnival day. So we helped to design the system, and that is effective for us because we don't have to worry about the skill level of any of our users. We know that the system is only going to be used one way, and that system, if used in that way, doesn't have any faults. The problem with developing a system where you don't know how people are going to use it, so people might have unexpected ways in using it, is that if you don't try and predict those in the system, when you actually write the system, you can often get unexpected results, which are errors. So things like runtime errors are errors where you haven't actually predicted what the user's going to enter. It can also be a problem if your skill level of participants is too high. So often they think that what they can understand, other people can't understand. Or if it's too low because they just have no idea how to create the system. But it is good for systems that may only be used by a few people. Agile methods are much more flexible methods of developing systems. So the idea is that they are based around teams, and the teams follow their own processes in developing the system. Essentially, you would still go through some sort of process, but it would be more team-based. So there would be more, I'm going to do this, and then after that, I'd like you to do this. So there's much more communication involved and much less structure. Once you've determined what the approach that you're going to use is, you need to figure out how the project's going to be managed and update the requirements report so that we know that everyone's on the same page. Because ultimately the requirements report is how your system is going to function, how it's going to be built, what processes you're going to follow after this stage. Then you get to designing. Now, depending on the system development approach, you're obviously going to use different design processes. For example, for the Agile method, you're probably not going to get to sit down and do a formal context diagram or data flow diagram. But for all of the approaches, somehow you need to identify and describe the detail of the new system's information processes. So you have to figure out how the system is going to collect information, how it's going to organise, analyse, store, and all the way down through to how the system is going to display information. If you don't know this before you start, then there can be problems at the end where you might have a system that you can only print out of, but with no printers. So it's very important to know from the beginning how each process is going to work. Then you would create some system model using tools such as context diagrams, data flow diagrams, decision trees and tables, and also storyboards. Once you've done that, you need to figure out what the data and information used is. So you need to do a data dictionary or perhaps a schema or entity relational diagram. Once the processing and your data information is understood, then you need to look at the information technology that will perform the front processes. Sometimes you might have to buy hardware or software or redesign hardware. Then you need to install it. Now you'll notice if you look through all of the processes that are involved, if I just go back with designing, it actually comes down to what the information systems diagram are. So if you imagine you have to cover the information processes, you have to cover data and information, you have to look at the people involved in the system, and you have to look at the information technology. It's all very important. Once you've designed the system, then you need to implement it. Now, implementing has to do with replacing the old system, but not just installing the system. You need to figure out how you're going to install the system, what method you're going to use to convert between the old and new system. The implementation plan will cover how participants are going to be trained, what method of conversion that you're going to use, how the system will be tested, so what data you're going to use. Are you going to use fake or real data? Because often fake data will act differently than real data, but then if you're going to use real data, then there's obviously a social and ethical issue you have to consider. And how you're going to convert data from the old system. So if you're organising data one way in one system and you need to organise it a different way in another system, how will you do that? Who will be responsible for converting the data and how will it be converted? What processes are you going to follow? Once you've decided on that, you need to look at training. So you can do a method of traditional group training where you would have one person come in and train a number of staff members, like in a traditional classroom. Or you could get people from your business that are already trained in the system to train each other. One important tool now is online training, which can be in the form of videos or text or hyperlinks. If you notice in the new version of Microsoft Office, it will actually highlight, for the Mac anyway, for the sections that if you go to help, it will highlight where you actually go to find things, which is one of the things that I use it for mainly because I know how to do stuff, but sometimes I don't know how to find where I want to do things. Aside from that, operation manuals, which are not so much used anymore for general users, but maybe technical operation manuals are important. Sometimes people like things on paper, particularly if they're not very technology based too. They like to actually have on paper some form of operating manual. So it's something to consider in your new system. The following are the 4 implementation methods for new systems and software. This is direct implementation. Basically, direct implementation means that you get rid of the entire old system, you implement the new system, the entire system, to everyone all at once. This means that the old system is completely cut out. It is higher risk, basically because the new system must be totally operational before you start implementing it, but it is used when it's not practical or possible to run both systems side by side. The diagram view looks something like this, with this being the old system and the new system starting over time directly after the old system finishes. The next one is parallel. Basically, this means that both systems are run at exactly the same time. This means that it's greater cost, but it does allow for problems to be fixed, and it also allows for user familiarisation with the system, particularly compared to the old one. It's more expensive because it means that you have to double entry, and double entry obviously means more time for people to work. So the diagram view looks something like this, with the old system still being in use while the new system starts. Then eventually, at a certain point, you'll get rid of the old system and just have the new system. So the new system and the old system is used by everyone. Then eventually you'll get rid of the old system. Pilot means that the new system is installed for a small number of users. For example, you might have a new system and software being used by the English department and the old system and software being used by all the other departments. So the English department are taking this on a trial basis. Eventually, the new system will go to everyone, and the English department can help with the training for the other parts of the people. This also allows greater error trapping, because if there's problems, it only affects a small amount of people. The diagram view looks something like this, with the old system being used for everyone, and then the new system being taken into place by just one part of the population, and eventually then the new system coming in totally. So at this point here, the new system comes in totally. At this point here, just the English department are using it until everyone starts using it. Phased allows for gradual implementation of the system by only using one part of the system. For example, here we have our new system software. We've got two parts. We've got the marking part and the reporting part. Now we might decide just to implement one part of the system, which is the reporting part, and we'll implement it to everyone to see how they go and whether they like it. Eventually then you would implement the marking part as well, but the phased part of the system is just part of the system. The diagram view looks something like this, with the whole system being used in the beginning. Then you'll gradually use less and less of the old system, and you'll gradually use more and more of the new system until, at this point, you're using all of the new system. And that's it. Testing and maintaining and evaluating is very important in your system. So if you implement the system and come back a year later with no testing, maintaining or evaluating the system, the likelihood is that the system will no longer be in existence. You need to make sure that the system meets the requirements. So has it actually solved the problem that you wanted to solve? So remember that if you get to this stage and you have suddenly discovered that it doesn't solve the problem, then it is very difficult to go back and fix it. So it's important that you test all the way through your system. You need to trial and use the operation manual, because often if you're creating an operations manual, then you are creating it in a level that you will understand, not necessarily what your users will understand. So it's important to get someone that knows nothing about the system and has no assumptions in the system to try and figure out what your operations manual means. You need to have some form of ongoing evaluation to monitor the performance of the system. Is it doing what you're doing? Are people using it? Are they using it easily? What is the effect on the users, participants, and also in the people in the environment? So it's important to have a look at the social and ethical issues, because if ultimately any system is designed to meet people's needs, if meeting their needs costs more than the social and ethical issues, in terms of not necessarily money costs, but in terms of issues cost, then the system won't be successful. You need to make sure that you maintain the system to ensure that any changes that need to happen, and so that it continues to meet the requirements. And sometimes you need to modify parts of the system if there's problems involved, because even if you're using real data, often you won't figure out what the problems are until the actual people that are going to be using the system start to have a look at it, because that, like I said before, you expect something to work in a particular way and your users don't.